Hi guys, welcome to this 20th tutorial in this series of programming PIC microcontroller with MPLAB XC8 compiler. This is part 1 of controlling a PIC microcontroller from a PC graphical user interface. In tutorial 19, we learned how to configure the PIC USART module using MPLAB code configurator. We learned that the PIC USART peripheral can be used for serial communication between a PIC microcontroller and a personal computer or other various devices supporting this type of protocol like other microcontrollers, GPS, GSM modem, and so on. In this example, we use 3 LEDs connected to port B. The red LED is connected to RB0, the yellow LED to RB1, and the green LED to RB2. If a 1 is received from the PC, it will switch on the red LED. If a 2 is received, it's going to switch on the yellow LED. And if 3 is received, it's going to switch on the green LED. We use Windows Terminal to send command from our PC to our PIC microcontroller. Let's run our simulation again. Welcome to studentcompanion.co.za. Press 1 for red LED, press 2 for yellow LED, and 3 for green LED. Basically, from the Windows Terminal emulator, we can send the command. If I press a 1, you can see the red LED switch on. I press a 2, the yellow LED switch on. I press a 3, the green LED switch on. And if I press any other character, it's going to switch off everything. Instead of using the Windows Terminal emulator, in this tutorial, we are going to design a graphical user interface using C# to send command to the PIC microcontroller to switch on these LEDs by just a click of a mouse. There are many advantages of using a custom graphical user interface application. If we had other devices connected to our PIC microcontroller, like let's say a DC motor or a temperature sensor or any other sensors, the graphical user interface can be used for remote monitoring and control. Data can be read from the PIC microcontroller and display on the graphical user interface, and the user can also control field devices from the PC, like switching on motors or even control the speed of the motors and so on. So let's start a new project with Visual Studio. Click New Project. We're gonna create a Visual C# project. Click on Windows. We're gonna use a Windows Form application. We're gonna name our project PIC GUI application. Select the location where you're gonna save your project. Select folder. Click OK. This is our main form. In the text properties, write controlling a PIC microcontroller from a PC graphical interface. We're gonna set some few properties. We're gonna disable the maximize box so that the user cannot maximize this application. Gonna need an icon. Gonna use this icon. Gonna need some few group boxes. If you need any control, you can find them under the toolbox. Gonna need 4 group boxes for this design. Gonna name the first group box red LED, and the name is gonna be group red LED. The second box, we're gonna name it yellow LED. The third box gonna be green LED. This is gonna be our COM port settings. We're gonna need 2 buttons, one to exit the application and the other one to connect and disconnect our serial port. Select a button. The text is gonna be connect. This one is gonna be exit. Button connect. Button exit. Just put some few icons Gonna need some few buttons for our LEDs. Let us insert a red LED background image. The name of this button is gonna be button red LED on, and it's not gonna be visible when we start our application. Only when the red LED is switched on, then this button is gonna be visible. So I'm gonna need another button to display when the red LED is off. This one is gonna be visible. I'm gonna name it button red LED off, and the background image, it's gonna be this background image of an LED which is off. So this is gonna be on top of the other, so you're only gonna see one button. I'm gonna do the same for the yellow LED and the green LEDs. So these are our LEDs. In the COM port settings, the first thing, we're gonna let the user to select the COM port that he's gonna use. When the user starts the application, this COM port combo box is gonna be populated with all the available COM port on that particular computer. The next setting is gonna be the baud rate. The user will have to specify the baud rate that is gonna use between this predefined baud rate. This baud rate is to be the same baud rate that the PIC microcontroller is running on. The next setting is gonna be the parity. Here the user can specify whether to use none, even or odd parity. The next setting is data bit. The user can specify to use either 7, 8 or 9 bit. And lastly, the user can specify whether the user is gonna use the stop bit as well. 1, 2 or 3 stop bit. Basically, this is how our graphical user interface is gonna look like. The first thing, once you run your application, you're gonna select your COM port, baud rate, parity, data bit and stop bit. Then you click on connect, and if the connection is established successfully, then you can send your control using these 3 LED buttons by just a click of a mouse. So let us write the code for all our buttons. We're gonna start with the simplest, which is gonna be the exit button. Once the user click on the exit button, it's gonna close the application. Double click. We're gonna say this dot close. The next button, we're gonna code the connect button. So double click connect. The first thing, before we use the serial port, we're gonna include the serial port namespace using system.io.port. So this basically is a namespace that contains the serial port class. So the first thing that we're gonna do, we're gonna initialize the COM port variable as a COM port. So we're gonna say private serial port COM port equals new serial port. This is going to initialize a COM port variable as serial port. So whenever we load our form, we're going to retrieve the list of all COM port available on the computer. Then we're going to populate our port name combo box items with all the port names. We're going to call this update COM port whenever the forms load. So double click on the form. This is going to create the form load event update port. Then whenever the connect button is clicked, it will check if the COM port is open. If it's already open, we're gonna call the disconnect function to disconnect the COM port. But if it's not open, then we're gonna call the connect function to connect our serial port. Let's start with connect function. We're gonna check if all the COM port settings are selected. If a COM port name is selected, baud rate, parity, bit, data bit and stop bit are selected. If they are not selected or any settings is not selected, you're gonna receive a message saying please select all COM port settings. But if all selected, then we're gonna set the COM port settings, the COM port name, the COM port baud rate, the COM port parity, data bit and stop bit. Then COM port.open always good to use the try catch method to open your COM port. If there is an error, your application will display an error message instead of freezing. So we're gonna say try, and if everything is fine, we're gonna open our COM port. But if there are some errors, then we can catch those errors. And if the COM port is open, then we're gonna change our connect button to disconnect. Then we're gonna enable our buttons group box so that the user can be able to click on the red LED, the yellow LED, and the green LED. But if the COM port is already open and the user click on the disconnect button, then it's gonna call the disconnect function. This basically is gonna close the COM port and it's gonna change the connect button text to connect. And here we're gonna disable all our buttons so that the user is not gonna be able to send control to the PIC microcontroller because the COM port is closed. So if we run our application, you can see all our buttons are disabled because we haven't established any connection. If you click on COM port, it's gonna load all the COM port on this machine. I've got 2 COM port. If I click on COM2, I can select the baud rate. They say 9600. Select parity. If I don't select all these settings and I click connect, I'm gonna get a message saying please select all COM port settings. So I'm gonna select all, the data bit to 8 and the stop bit to 1, then click connect. You can see I've established connection and my LEDs are enabled. I can be able to click on these LEDs. If I click on disconnect, it's gonna disconnect and disable all our LEDs, and it's gonna change the text to connect. Click on exit to exit the application. Let us code our LEDs buttons code. Gonna start with the red on button. If this red button is displayed, it basically means that the red LED is already on. Then if I click on that red LED, it has to be off. In this example, I'm gonna send the character 4 to switch off all LEDs. Remember, with our application, if we send character 1, is gonna switch on the red LED, 2 the yellow LED, 3 the green LED, but any other character is gonna switch off all the LEDs. So in this example, I'm just gonna send the 4 to switch off all LEDs. And if the user click on this button, it should send a 1 to the serial port. Gonna declare character buff variable and the size is gonna be a 1. We're gonna use the comport.write class method to send a single character to the serial port using data from the buffer. In this case, the buffer value gonna be 1. Then we're gonna disable the red LED off button and enable the red LED on button so that the user can see on the graphical user interface the background image of the red LED button display an LED which is on. The yellow LED and the green LED should be off. We're gonna do the same for the yellow LED and the green LEDs. For the yellow LED, to switch it on, we're gonna send the character 2, and to switch it off, we're gonna send the 4, which is basically the same. If we send anything, either 1, 2, or 3, it's gonna switch off everything. And lastly, the green LED button. To switch on the green LED, we're gonna send 3. And basically, once the green LED is on, we're gonna switch off the yellow and the red LEDs. So let us run our application. You can see all the LEDs are disabled. I'm gonna select a COM port. I'm gonna select COM port 2, 9600, parity none, data bit 8, stop bit 1, click connect. Connection established successfully. If I click on the red LED, you can see it displays the red LED which is on. If I click again, it's off. If I click on the yellow LED, the green LED, and so on. So basically, this is how our application is gonna work. You just have to click to send the command to the PIC microcontroller. I'm gonna click disconnect. Let us run our simulation. We're gonna use the same code as in tutorial 19. We're not gonna change any code. Whenever the PIC receives a 1, it's going to switch on the red LED, a 2 a yellow LED, and a 3 a green LED. As we have already explained in tutorial 19, to connect a PIC microcontroller to a PC, you need to convert the voltage levels because the PC uses a different RS-232 voltage levels compared to the PIC microcontroller, which uses 0 for low and 5 for high. We use this chip, the MAX232, to convert our voltage levels. In this simulation, we're gonna use the Proteus COM-PIM component. Under the component, click on COM-PIM. So this is a port physical interface model. This COM-PIM component is a physical interface model of a serial port. Incoming serial data is buffered and presented to the circuit as a digital signal, while serial digital data generated by a PIC USART model appears at the PC physical COM port. So if you want to interface with a real physical COM port of your computer using Proteus simulation, then the component to use is COM-PIM. The COM-PIM model also provides for baud rate translation and for optional hardware or software handshaking on both physical and virtual side of the device. This allows any real-world hardware equipped with a serial port to interact with a Proteus virtual simulation. For example, you could use it to develop a program for microcontroller with Proteus VSM that will operate a real physical modem. We're just gonna delete this. The TXD pin of the COM-PIM should be connected to the TX pin of the PIC microcontroller, and the RX pin of the PIC microcontroller should be connected to the RXD pin of the COM-PIM. We need to set the COM-PIM properties. Right click, edit properties. You can set the physical baud rate you're gonna use. This example we're gonna use 9600 because it's the baud rate that we specify in the code that is running inside this PIC microcontroller. The virtual baud rate is gonna also be 9600. The parity is gonna be none, and the data bit is gonna be 8. Click OK. Let's run our simulation. Run, and this is our graphical user interface. Gonna click connect. Then if I click on the red LED, it's gonna send a 1 to our microcontroller. It's gonna switch on the red LED. If I click on yellow, it's gonna switch on the yellow LED, and if I click on the green, it's gonna switch on the green LED. So instead of just sending the command with the Windows terminal emulator, we can design our custom software depending on our need to send the command to our PIC microcontroller. And that's all, guys, for this tutorial. In part 2, we're gonna continue with our graphical user interface project. We're gonna generate a setup project that you can install on your PC. Thank you guys for watching this tutorial. Don't forget to subscribe to this YouTube channel to receive more tutorials in the future. And I'll see you guys in part 2. Thank you.